In the first part, we talked about the Filecoin Onchain cloud at a high level and introduced the layers that make it work. Now we'll deep dive into the storage and payment flow of how to get your data stored and how to retrieve it. Before any data is uploaded, the payment side is set up. Filecoin Pay operates on a deposit-first model. Funds are deposited into your account upfront, and services draw from that balance only when they deliver verified work. You also approve the storage service to spend on your behalf. This approval defines limits, how much can be charged and how much balance needs to be maintained. For warm storage, there's a required buffer of roughly 30 days of storage cost, and if the balance drops below that level, providers are allowed to stop storing the data. The Synapse SDK handles the deposit and approval in a single step. Once that's done, the account is funded, permissions are set, and no funds have moved yet. Now the upload begins. When you upload a file through the SDK, the data is processed into what Filecoin calls a piece. A piece is a standardized unit of storage. As part of this process, the data is hashed into a Merkle tree. The root of that tree becomes the PCID, the cryptographic identifier to the data. Any change to the data produces a different PCID. That identifier defines exactly what is being stored. The SDK then selects a storage provider. Providers advertise pricing and capabilities on-chain, and selection can be automatic or explicit. The data is uploaded to the selected provider, and the storage agreement is registered on-chain. The piece is recorded as part of a data set along with parameters like duration and pricing. At the same time, a payment rail is created linking your Filecoin Pay balance to that provider for this data. At this point, the data is stored on the provider's hardware, fingerprinted by its PCID, and connected to your wallet. Now verification begins. Storage providers are required to continuously prove that they still possess this data. The PDP contract issues challenges at regular intervals, and these challenges are generated using decentralized randomness with the DRAM beacon and can't be predicted in advance. Each challenge requires the provider to prove possession of specific positions in the Merkle tree for the data. If the provider has the data, it generates a proof from its local copy and submits it on-chain. The verifier contract checks the proof, valid proofs are recorded, and invalid proofs fail. Payments follow verification. When a proof succeeds, the corresponding time period is marked as service delivered. As verified time accumulates, the payment rail settles and funds are transferred from your Filecoin Pay balance to the provider. If a provider fails to submit a valid proof, payment does not occur for that period. And now retrieval. Retrieval works through the same content address mechanism. You request data using its PCID, a provider returns the raw bytes. The SDK recomputes the hash from the received data and compares it to the PCID. If it matches, the data is confirmed to be exactly what was stored. For faster delivery, there is also the optional layer of a content delivery network, or CDN, called Filecoin Beam. Filecoin Beam caches frequently accessed data closer to its users, reducing retrieval latency while preserving verifiable delivery. We'll deep dive into retrieval later in this course. Stepping back, the full life cycle looks like this. Funds are deposited and permissions are set. Data is uploaded and identified by a PCID. A provider stores the data and registers the commitment on-chain. Continuous proofs verify storage over time. Payments settle only when proofs succeed. Data can be retrieved and verified at any point. Each step is connected. Storage creates proof obligations, proofs control payments, payments incentivize continued storage, and that's the whole system.